This is the third FRQ for the 2019 BC exam. So they give you a continuous function that it's defined on the interval from -6 to 5. And if you notice, that's not this picture. This picture is from -2 to 5. So the figure above shows a portion of that, and you have line segments. You have a quarter of a circle centered at 5, 3, and then they gave you this point. So we're going to be using all of that information. So they tell us that if the interval from -6 to 5 is 7, they want us to find the value of -6 to -2. And then show the work that leads to our answer. So this is using properties of integrals. And so if you have the integral from -6 to 5, then that's going to be -6 to -2 plus -2 to 5. And so that's why they give it to you the way they do, is that -2 to 5 is the picture. And so if you can find that, then you can solve the rest of it. So up here we have 7 equals, I'll just call it y, plus whatever that happens to be. So that means I'm going to go ahead and I'm going to need to find that area. So this little triangle, first I've got 1/2 times a base of 1 times a height of 1. So that's an area of positive 1/2. That means that this right here is an area of -1/2. Then I've got 1/2 times a base of 1/2 times a height of 1. So this is an area of -1/4. Then right here, I have 1/2 times a base of 1.5, which is 3/2, times a height of 3. So that is an area of 9/4. And then the trickiest part here is this, because they didn't give you, like, I feel like these problems a lot of times they give you the circle part. So they'll say, like, this is a quarter circle and it's the inside of the circle that you're finding, and then you can just do pi r squared. But that's not what this is. This is the outside of the circle. So what I did to make more sense of it in my brain is I made a square and I put a circle inside of it. And then I said, okay, the part of the picture that I'm looking at is actually like this part right here. If you can see that, that's this. So these parts are the same. So then I put some labels into this picture. I said, okay, here's the center of the circle. It's got a radius of 3. So that means that the whole square is a 6 by 6 square. So for me to find this area right here, I said, okay, first we would have to find the area of the entire square, so that's 36. Then I'm going to subtract off the area of that circle, which is pi r squared. And then because it's only 1/4 of the whole thing, I'm going to multiply that by 1/4. So I got 1/4 times 36 minus 9 pi. And so I got 9 minus 9 pi fourths as the area for that piece right there. And I think that was the hardest part of that whole problem. 9 minus 9 pi fourths. Okay, so if I'm going to go ahead and put all this together, then I'm going to say for that area, I've got 1/2 minus 1/2 minus 1/4 plus 9/4 plus 9 minus 9 pi fourths. That's the entire, sorry, you couldn't see any of that. That was me just writing down all those different areas that I just found and kind of adding them up. So these two cancel. -1/4 plus 9/4, that's 8/4, which is 2. 2 plus 9 is 11. Okay, so then what I'll go ahead and do is subtract the 11 over, that gives me -4. Add the 9 pi fourths over, that equals y, and so that means that -6 to -2 f of x dx is -4 plus 9 pi fourths. Now, if you are nervous about doing this mental math or simplifying, you could leave that, honestly, you could leave this as an entire chunk and just do 7 minus this entire chunk and write that down and you would still be right. So you don't necessarily have to do all that simplifying that I did. All right. Next, for part B, we have the integral from 3 to 5 to f prime of x plus 4. So this is just a straight up integration problem. So I have the integral of 2 times f prime of x would just be 2f of x. The integral of 4 is 4x, and that's being evaluated from 3 to 5. And so that means I've got 2f of 5 plus 4 times 5 minus 2f of 3 plus 4 times 3. And then f of 5 is 0. So that kind of zeroes this out. F of 3 is, oops, decimal. I'm not going to estimate that. That's when I remembered that this was over here. So I actually have 2 times 3 minus square root 5. Okay, so for the first parenthesis, I've got 20. And then in the second parenthesis, I have 2 times 3 minus square root 5. So I have 6 minus 2 root 5, and then that's plus 12. So I have 20 minus 18 minus 2 square root 5. And honestly, after you get to the point where you plug the numbers in, you could leave it. So it would probably be smart to just leave it like that and call it good. But I always have to finish these problems, so I do not recommend it on the exam, though. So that's your final answer there. All right. Part C says G is given by this. This is the second fundamental theorem of calculus. And so let me just go ahead and write what we have. We have G of x is -2, I think. Yeah, -2 to x f of t dt. So before I went any further, I just went ahead and did the second fundamental theorem of calculus on this. So I said G prime of x is f of x times 1 minus f of -2 times 0. And so the derivative of G is the same as the function of f. And so that means that the picture now is giving me the derivative of a function. And so if I want to find the absolute maximum value, then I need to use the endpoints for the extreme value theorem. But I also need to use any points on that interval that look like a maximum. So from -2 to 5, you have this, which is positive to negative. So that's a switch from increasing to decreasing. And then over here, we have negative to positive. So that's a switch of g of x from decreasing to increasing. So that means I'm only going to look, I need to look at -1, but I also need to look at -2 and at 5 for those endpoints. So I'm going to go ahead and say, okay, the x values that I'm considering are -2, -1, +5. And then to find g of -2, I have to do the integral from -2 to -2. And it's the same number to itself, so it's 0. And then for g of -1, I have to do -2 to -1. And -2 to -1 is +1/2. I already did the work for that. And then g of 5 is -2 to 5. And I already did the work for that as well. -2 to 5 is this whole thing. And you have two options. You could take this and just write down all of that if you chose not to simplify. Or if you did choose to simplify, then you can do -4 plus 9 pi fourths. No, sorry, that wasn't right. That wasn't -2 to 5. Was that -2 to 5? Sorry, I grabbed the wrong part. It was this. Sorry, you can do this whole thing, or you can do this. 11 minus 9 pi fourths. I was thinking -6 to -2. 11 minus 9 pi fourths. So before you decide, you have to figure out which one of these is biggest. So 0's out of the running, probably. well, 1/2 is bigger than 0, so it's definitely out of the running. And then here, I had to figure out approximately how big that was to make sure it was positive, to make sure it was bigger than 1/2. And so I just said 11 minus 9 times pi is like a little bit bigger than 9 times 3, which is 27. 27 divided by 4 is similar to 28 divided by 4, which is 7. So this is somewhere around 4. It's not exactly 4, but it's somewhere in that ballpark, which means that this is definitely bigger than 1/2. And so you have an absolute max value of 11 minus 9 pi fourths. And this work is justification enough. I probably wouldn't leave this here. I would scratch it out or whatever, but that's the answer that I have for part D.